Hello and welcome to this new lesson in which we are going to design our circuit. Now, we will use a soil moisture sensor to measure the volumetric water content in the soil, and we will mainly use the DHT11 sensor, which we will use to measure temperature and humidity levels in the plant's surroundings. And the water level sensor will measure the water level in a small tank, and this is an optional sensor. You can choose to add it or not depending on your water let's say state. If you have a continuous water supply, you shouldn't worry about the tank level. Now, to design our circuit, what we need to do is simple. We will need to open up the Freising app that we just downloaded. Double click on it. Now this will simulate the real life connection, so you need to concentrate. Go to the breadboard view up here and you will see a breadboard. Now move this aside. We will need ESP32 board, and as you can see we have a lot of ESP boards. We need the ESP32 board, this one. Okay, now we will also need a relay module. Now you can see that here we have a lot of relay modules, a lot of components. We will take this one. We will need a DH11 sensor, DHT. Okay, let's try another way. Okay, when you face this problem, when you try to add a sensor and you don't find it, let's try another name. This means that this sensor is not here. And as you can see here, we have one of these sensors. It's called RH sensor. And we can see that it almost have the same terminals, ground and VCC and data signal. So we can use it for this connection. And you can either look for an alternative or you can download it online. A lot of libraries are already available by people who are creating these components, so you can download it and add it, but this will take a lot of time, so we will use this instead. Now we need the soil moisture sensor, and this is it. We will need the water level sensor, and when you look for it you won't find it. So in this case you need to go to Google here, and in here write water level sensor Freising. As you can see, you'll get water level. Okay, this is a water level indicator. Let's look for the image search. Okay. There is more than one. Let's try test water level Freising. Go. Okay, the first result is this. As you can see, this is the water level sensor, and this is the Freising that we are going to download. It has a water level sensor connected to Arduino, and we only need this item. So download the Freising file from here. Here it is. Now to open it up, you need to go to Freising, drag and drop the file on your open Friday software, you will see that now you have a new window, and this is the water level sensor. Now what you need to do is simple copy and paste the sensor, and here you have it. Sorry. Okay, now let's connect these items to our ESP board. We will start with the DH sensor. We know that we need ground connection, which is the black one, and we will also need 5 volts. So in order to get our 5 volts, we need to make sure this VN pin will provide you with 5 volts, and you need to make sure that you know what you are doing, because if you connected your ESP board through USB, you will get 5 volts from this VN pin. Otherwise, you have to connect an external power source that provides 5 volts. Now, we need to connect the first sensor which is the DH sensor. Now, as you can see, here we have more than one terminal that we need to connect, and depending on the terminal that you are trying to connect, now we need to connect the VCC and ground. Now the VCC must be connected here, but we need to connect the red wire here and the black wire here, just to make sure that we have power up there, black. Okay, now the VCC will be connected here. Now we have other terminals. This is the data signal, and we will send it to our ESP32 board. Let's send it to this pin. Carry this pin, and let's connect it to pin number 32. Change the color to yellow, and here we have the ground pin, and we must connect it to ground. Change the color to black, and this one to red. Now this pin is the second ground, and you can connect it to ground here. Depending on the module that you have, you can check the datasheet for the connection, but this is the connection for the one that we have here. Now to connect the relay module, we can't use this one as it has a lot of input output pins and it's a dedicated module. So let's remove these. I already downloaded a relay module, and I'll provide a link for you to use it. This is it. You can drag it and drop it on your FriedZing, and as you can see here we have it. You just need to drag this relay module and drop it here. Now we have these 3 pins. The signal must be connected to your board, and let's choose a different color, let's say green, and the plus must be connected to the 5 volt. The minus must be connected to ground, and we can change the coloring to black and yellow or red. Okay, now we come to this module, which is the water level module. We need to connect the plus to 5 volts, the black to the ground, which is the minus, and the signal can be connected to D21. Now Let's change this to, let's say, orange. Now we have 3 signals, 1 output and 2 input from sensors. We also have another sensor, which is this one, the soil moisture sensor. Now let's connect the ground to the ground, the VCC to the VCC, and the signal to D19. Let's choose a different coloring, and that's it. I will change the color to red, and this one I will change it to black. Now we have connected the soil moisture sensor, the water level sensor, the humidity and temperature sensor as input, and we have connected the relay as output. I will save the design. Let's call it circuit design. I will provide this circuit design and the resources so that you can get these modules for your freezing design. Now, again, make sure that you take a note of all of these sensors. Now we have the relay connected to pin number 22. So let me open up a notepad. Okay, right click, new notepad. Let's call it pins. Now inside it, we need to make sure that we have everything. Now DH sensor is connected to D23. Relay is connected to D22. And water level is connected to D21. And soil is connected to D19. As you can see here, D19, D21, D22, and D23. This will be used in the coding section. Now you can see the schematic for your design here. As you can see, you can arrange these components, and you can also make the wiring. You can rotate these items. You can auto-route them so that they are connected with wires. As you can see, freezing is trying to wire these components together. As you can see here, we have a problem. So you need to manually route this. And you can even create a PCB design by moving these components, or at the very least increasing the size of this layout. Now, as you can see, it's a piece of cake, and you can also use auto route. Click on auto route. It will take some time. Then you will get your PCB design ready for manufacturing. Now there are still some wires that you need to route manually. As you can see, this one, you need to connect a wire from here to here manually. And you can do the same for the rest of these wires. And as you can see, you can then move to fabricating, and that's it. Thanks for watching this lesson. If you have any question, please ask in the Q&A board. This is Ashraf from Educational Engineering.